Alright, so, I'm going to do what I'm going to do. I don't know.
Explain the question. Read the question. Explain the problem.
Alright, so...
Maybe you do need a cigarette.
No.
Okay.
I'm good. Alright, so... 3, 2, 1. Alright, so I'm going to go over a heating curve question. And, alright, let's start. So, suppose that 0.95 grams of water condenses on a 75 gram block of iron that is initially at 22 degrees Celsius. If the heat released during condensation goes only to warming the iron block, what is the final temperature? Alright, so we know we need to use this equation because there's going to be no phase change. We know that because it says it's only going to go to warming the block. Alright, and out of this delta T, we want to isolate the final temperature. Yes, we want to isolate the final temperature. And we're going to do that by first rearranging the equation. We're going to move the moles and the specific heat of both of iron. We're going to move them over to this side. And then we're going to rearrange this side and label our things, I guess. This is just practice. It's practice for now. We're just going to rearrange it where we have moles of water times kilograms of water divided by, times kilojoules of water divided by joules of iron times grams of iron. We're going to split up our delta T, and we're going to bring our initial temperature of iron over to this side, so we isolate our final temperature of iron. And so what does it look like when we actually do the equation? Okay, so using units of dimensional analysis, we're gonna write our grams of water up here, and the grams of a mole of water. This is gonna give us our moles of water. Then we are going to get our specific heat of vaporization of water. Write that there. We're gonna have kilojoules and we want joules, so we're gonna write 1,000 joules on top and 1 kilojoule on the bottom there. This is gonna be our specific heat of iron. You're gonna write the grams Celsius up top and the joules in the bottom, and then this is our grams of iron. All right, so we are gonna cross out our units. Grams crosses out with grams, moles crosses out with moles, kilojoules crosses out with kilojoules, joules crosses out with joules, and then grams crosses out with grams, leaving us with, if you pull your calculator out, it's going to give us 69.67 degrees Celsius. Not too significant, not too sig figs. It's just, we'll do that at the end. Alright, so now that we have our, what do we have here? We have our initial, which we got from the problem, and we're going to add that to the temperature, the change in temperature that we just isolated, and just some simple arithmetic gives us our final temperature, which is 91.67. Rounding it up, we get 92 degrees Celsius. And a couple numbers you had to look up is our specific heat of iron, 0.444, Google that, and our heat of vaporization of water, which was assumed, and it was somewhere in the book. All right, there we go.
That's it.
All right.